Hello students. In this session for B.Sc Chemistry first semester, session both 62 and 63 with the paper General Chemistry and the topic stoichiometry, under that calculation of equivalent mass of acids and bases and also equivalent mass of salts, oxidizing and reducing agents. Let us know the definition of what is equivalent mass of an element. The number of parts by mass of the element that either combines with or displaces 1.008 parts by hydrogen or 8 parts by mass of oxygen or 35.45 parts by mass of chlorine or one equivalent mass of any other element. So we can write it as, in order to determine equivalent mass, we are going to calculate molecular mass by X, where the value of X is calculated for different type of compound by different ways. So let us pass on to equivalent mass of compounds. First, let us take up acid. An acid is a substance which contains one or more replaceable hydrogen atoms. Basicity of an acid can be defined as, basicity of an acid is the number of replaceable hydrogen atoms present in a molecule of an acid. Let us see some examples here. So acid and its basicity is monobasic acid. These are all examples for monobasic acid, that is hydrochloric acid, nitric acid, formic acid, acetic acid, where only one replaceable hydrogen is present. So they are called monobasic acid. For dibasic acid, that is where two replaceable hydrogen atoms are present, sulfuric acid and oxalic acid. And for the third example, that is orthophosphoric acid H3PO4, where you find it is tribasic acid with three replaceable hydrogen. Excuse me. Equivalent mass of an acid, it is the number of parts by mass of an acid which contains 1.008 parts by mass of replaceable hydrogen. So equivalent mass of an acid is given by molecular mass by basicity. We'll look into some examples. Equivalent mass of HCl is, its molecular mass is 36.5 divided by 1, where 1 is, it is having, its basicity is 1, it is nothing but it has one replaceable hydrogen, so its equivalent mass is 36.5. Similarly, for dibasic acid, that is sulfuric acid, where two replaceable hydrogen is present or 2 is its basicity, its molecular mass 98 by 2 gives you 49 is the equivalent mass of sulfuric acid. Similarly, if we consider oxalic acid crystals, that is with two molecules of water, its molecular mass is 126 divided by its basicity is 2, or it is having two replaceable hydrogen, then its equivalent mass is 63. So similarly, equivalent mass of, if you consider anhydrous oxalic acid, rarely we may use this. So here it is 90 is its molecular mass divided by 2 replaceable hydrogen, and its equivalent mass is 45. Let us consider base now. So we all know base is a substance which reacts with an acid to give salt and water. Acidity of a base. Acidity of a base is the number of molecules of a monobasic acid required to neutralize one molecule of a base, or it can also be defined as the number of replaceable hydroxyl groups present in a molecule of a base. So, with respect to this first definition, the acidity of a base can be found out by writing a balanced chemical equation for the neutralization of one molecule of a base with a monobasic acid. Let us consider this one molecule of a base, that is sodium hydroxide, with a monobasic acid. We get salt and water, that is sodium chloride and water. So from the above example, the acidity of sodium hydroxide is 1. Hence, it is called as monoacidic base. So, sodium hydroxide is having one replaceable hydroxyl group. It is monoacidic base. Similarly, calcium hydroxide has two replaceable hydroxyl group. It is diacidic base. Similarly, aluminum hydroxide has three replaceable hydroxyl group. So, it is triacidic base. Let us pass on to the calculation of equivalent mass of a base. Equivalent mass of a base is the number of parts by mass of a base required to neutralize one equivalent mass of an acid. So similar example, let us take sodium hydroxide neutralized with HCl to form sodium chloride and water. In the above reaction, 40 gram of sodium hydroxide requires 36.5 gram of HCl. So, therefore, the equivalent mass of sodium hydroxide is here 40. Similarly, let us take up one more example. Calcium hydroxide is neutralized by HCl to form calcium chloride and water. In the above reaction, 74 gram of calcium hydroxide requires 73 gram of HCl. That is, here for 1 gram equivalent of calcium hydroxide, it is 2 gram equivalent of HCl is required to neutralize. Then the amount of calcium hydroxide required to neutralize 36.5 gram of HCl is 37, half of this. Therefore, the equivalent mass of calcium hydroxide is 37. In general, the equivalent mass of a base is equal to molecular mass by acidity. We'll look into the example. Equivalent mass of sodium hydroxide is 40 by 1. What is 1? Its acidity, or it is the number of replaceable hydroxyl group. So the answer is 40. Similarly, equivalent mass of calcium hydroxide, it is 74 by 2, where 2 is its acidity or 2 replaceable hydroxyl group. The answer is 37. Similarly, equivalent mass of aluminum hydroxide is 78 by 3 is equal to 26. Let us pass on to equivalent mass of a salt. Equivalent mass of a salt is the ratio of molecular mass of the salt to the total cationic or total anionic charge. Let's look into the example. To calculate the equivalent mass of anhydrous sodium carbonate, that is Na2CO3, we know its molecular mass is 106. But if you consider its cationic charge, it has 2 sodium atoms, 2 Na plus, and sodium is carrying +1 charge, so it has 2 cationic charge. Or if you consider anionic charge, it has carbonate CO3 and its charge is 2 minus, and it has 2 is the anionic charge. So the equivalent mass is 106 by 2, where 2 is either total cationic charge or total anionic charge, and the answer is 53. So the equivalent mass of sodium carbonate is 53. Similarly, equivalent mass of sodium chloride is, its molecular mass is 58.5 divided by 1, where 1 is the number of anionic or cationic charge here is Na plus or Cl minus. So it is 1, hence its equivalent mass is 58.5. Similarly, equivalent mass of sodium carbonate, just now we have calculated, it is 53. And for the calcium carbonate, its equivalent mass is 100 divided by 2, where 2 is Ca2 plus or CO3 2 minus. So either if you take cationic or anionic total charge, it is 2. So its equivalent mass is 50. Similarly, equivalent mass is of KCl is 74.5 by 1, where the answer is 74.5. Let us pass on to equivalent mass of oxidizing agents. So it is given by molecular mass by number of electrons gained or molecular mass by change in oxidation number. Let us look into one example. Equivalent mass of potassium dichromate in this reaction. So Fe2 plus, if you take ferrous sulfate, which is the reducing agent, and potassium dichromate is the oxidizing agent. Here, dichromate is reduced to chromium, Cr3 plus, whereas ferrous is oxidized to Fe3 plus. So dichromate is an oxidizing agent and it gains 3 electrons per atom of chromium. That is, oxidation number of chromium changes from +6 to +3. That is +6 minus 3. That is, the answer is +3. So since in dichromate ion there are 2 chromium atoms, you can see here Cr2. So equivalent mass of dichromate is molecular mass by 6, because 3 into 2 is 6. So the answer is 49. Similarly, equivalent mass of reducing agent is given by molecular mass by change in oxidation number, or you can consider molecular mass by number of electrons lost. So in the same reaction, Fe2 plus is the reducing agent and it is oxidized to Fe3 plus, where it has lost 1 electron. So its equivalent mass of Fe2 plus is molecular mass by 1. So its molecular mass is 55.8 by 1 is 55.8. So references I have made Bhal and Bal and Tully GD, Essentials of Physical Chemistry, Principles of Physical Chemistry by Puri, Sharma and Patania, and also a textbook of Physical Chemistry by Negi AS and Anand AS. You can refer any physical chemistry textbooks which gives information about stoichiometry and also the information about equivalent mass of different compounds, what we discussed in this session. It is Digital Learning Department of Collegiate Education is presenting these videos for you.